some kind of karate. They kick and they punch, and then it doesn't end until blood is shown.
Tai Chi, I think it's a form of martial arts. You sure it's not like a tea?
It reminds me of a tea.
Like chai tea?
Chai tea.
Tai Chi.
But I think it's a type of martial art.
Okay.
As you can see, people vary widely in their beliefs as to what Tai Chi is. Tai Chi is formally known as Tai Chi Quan, which literally translates as boundless fist. Tai Chi is a reference to the dynamic balance between yin and yang, while Quan simply means fist. According to our research, Tai Chi originated as a martial art in China during the Ming Dynasty, and currently there are two forms of it that are still practiced, the Chen and Yang styles. The purpose of our project is to answer the question, how does Tai Chi work? More specifically, we'll be looking at the biomechanical aspects of certain techniques within the Chen style of Tai Chi.
In order to learn more, the members of the Tai Chi project invited Master Chen Xiong from Beijing, China, one of the most highly regarded Tai Chi masters in the world, to the Motion Gate lab at Stanford University. Using high-tech infrared cameras and sophisticated motion capture software, we were able to collect kinematic data as the master demonstrated his techniques. Based on this motion capture data of Master Chen, we have come up with hypotheses regarding the detailed biomechanics of his movement.
In attempting to answer the question of how Tai Chi works, we very closely watched the motion capture videos of Master Chen. As we watched, we realized that one of the distinctive movements captured was the movement and placement of his leading leg during his strikes. As a first step in understanding Tai Chi, we decided to focus our question to what is Master Chen doing when he is placing his foot down. Does this action contribute to the effectiveness of his strike? To answer this question, we first decided to measure the relative timing of his stomping motion to the strike. To do this, we plotted the velocity data from his foot on the same graph as the position data of his hand. By comparing when his foot velocity was 0 and thus was on the ground, to when his hand was outstretched the most, which is the position at which he is making contact with his imagined opponent, we noticed that the foot comes down before the hand. This suggested to us that Master Chen's leading leg was somehow being used to help stabilize or power his strike.
The logical segue is then, if his foot contributes to the strike, how does this work? It is possible that putting down his foot generates rotational momentum through Master Chen's feet, hips, and shoulders that becomes transferred into his arm for the strike. This would follow the law of conservation of momentum, which when applied to our situation, states that the rotational momentum is converted into linear momentum in Master Chen's arm. To test this, we drew axes and evart from Master Chen's feet, hips, and shoulders, and generated angular position, velocity, and acceleration graphs for these three parts of his body. We then analyzed the peak angular velocity for each and the relative timings to see if there is momentum being propagated starting at his feet, proceeding through his hips and shoulders.
Another question that we had was whether another factor contributes to the force of the master's strike, the physical principle of impulse. Impulse is defined as the change in momentum and is the product of the magnitude of force applied and the amount of time over which the force is applied. Therefore, our hypothesis was that the master utilizes the principle of impulse by minimizing the amount of time over which he applies his force, thus greatly increasing the magnitude of the force. We measured the timing of the strike by graphing the distance between the hand and shoulder across time. We then determined the length of time of the strike by measuring the time over which the distance remains constant at its peak value. After conducting this analysis, the results indicated that the strike is applied over an extremely short time, 5/1000ths of a second. So with all of these results put together, we built a timeline of all of the key biomechanical events that occurred during the strike. We can use this as a starting point for further studies in analyzing the fascinating biomechanics of Tai Chi.